Hi everyone. Today we'll learn what critical numbers are, why they're useful, and how we can find them. In the first exercise, we must identify all local extrema of the following function. If you would like to try this exercise on your own first, stop the video now. You can download these notes using the link in the video description. If you are not sure how to find local extrema, said differently, how to find local maxima and local minima, I will add a link in the video description to a video where I explain how to find local extrema of a function using a graph. I believe this function has two local maxima. One occurs at -1 and that local maximum is 2. Another one occurs at 3 and equals 4. There are two local maxima, one 2 and another one 4. This function also has two local minima, one at -3 with a value of -2 and another one at 1 with a value of -1. Note that the endpoints cannot be local maxima or local minima because the endpoints are not the interior points of the domain. There is something special about places where local maxima and local minima occur. Note that in these places, the derivative is either 0 or doesn't exist. At -3, the tangent line is horizontal, the derivative is 0. At 1, the derivative is again 0. At 3, the derivative is again 0. And at -1, there is a sharp corner, which means that the derivative doesn't exist. It appears that local extrema often occur at places where the derivative equals to 0 or where the derivative doesn't exist. Inputs where the derivative equals to 0 or the derivative doesn't exist have a special name. They are called critical numbers. Given an interior number in the domain, we say that C is a critical number if one of the following conditions is satisfied. Either the derivative doesn't exist there or the derivative equals to 0. And note again that a critical number must be the interior point of the domain of the function f. It cannot be the endpoint of the domain. Let's see if we can identify the critical numbers of the following function. If you would like to try this problem on your own, stop the video now. I believe there are a few places where the derivative is 0 or the derivative doesn't exist. One happens at -4. That is where the derivative is 0. Another one happens at -3. At -3, the derivative doesn't exist because I have a corner. Then the next place where the derivative is 0 or doesn't exist happens at 1. I have a horizontal tangent line there. And finally, at x equal to 2, I have a corner, which means that there are 4 critical numbers here. Number -4, -3, 1, and 2. Note that at -4, I have a local minimum. At 1, I have a local maximum. At 2, I have a local minimum. However, at -3, I do not have a local max nor local min, because no matter what interval I draw around -3, the piece of the graph will not have a maximum at -3 or minimum at -3, because points on the right are always taller and points on the left are always smaller. This means that critical numbers can, but don't have to give us local maxima or local minima. Let's take a look at this example to make sure we understand that critical numbers are simply candidates for local maxima or local minima. In the first example, we have a critical number, -1, the derivative doesn't exist there, and we have a critical number at 1, or critical number 1, because there is a derivative equal to 0 there. And in both places, I have some kind of a local extremum. At -1, I have a local min, and at 1, I have local max. Let's write that down so we remember that over here I have a local min at x equal to -1, and I have a local max at x equal to 1. So these critical numbers give us local minima and local maxima. Let's take a look at the second example. I have two critical numbers there. 1 is a critical number because there is no derivative at 1. 2 is a critical number because the derivative there is 0. However, there is no local max or min at 1 or 2. There is no local max or min at 1 or 2. Again, critical numbers can, but don't have to give you local maxima or local minima. Let's learn how to find critical numbers algebraically. Given a function, we are looking for places for x's where the derivative doesn't exist or the derivative equals to 0. Let's first find the derivative and see, are there any x's for which this derivative does not exist, and are there any x's for which this derivative equals to 0? I take the derivative using the power rule, and I get x squared minus 5x plus 4. And now I need to ask myself two questions. Is it possible for this derivative to not exist? Are there some x's that make this derivative not defined? And then I need to ask myself, are there some x's that make this derivative 0? This is a polynomial, which means it's defined for all the x's. There are no x's that make this derivative undefined. The derivative always exists. So this condition on the left gives us no critical numbers. Can I find any critical numbers when I set the derivative equal to 0? I get x squared minus 5x plus 4 equals 0. Let me factor this to solve, and I get x minus 4 multiplied by x minus 1 gives me 0. This tells me that there are two places where this derivative is 0. It is x equal to 4, and it is x equal to 1. These are critical numbers. Do they give local maxima and local minima? We don't know yet. We will learn that in one of the future videos. Let's try one more problem. If you would like to try it on your own first, stop the video now. We're given a function, we must find critical numbers of that function. I start by taking the derivative of the function. To take the derivative, I apply the chain rule. The inside function is x minus 1. The derivative of that is 1. The derivative of the third power is 1/3, whatever was inside of the root, to the power -2/3. This can be rewritten as 1 over 3x minus 1 to the power 2/3, which is the same thing as 1 over 3 root of, in fact, a third root of x minus 1 squared. Now I ask myself two questions. Are there some x's that make this derivative not defined? And are there some x's that make this derivative equal to 0? Is it possible that f prime of x does not exist? And is it possible that the derivative equals to 0? Let's start with the condition on the left. Are there some x's that I cannot plug in here? And I believe there is one such x equal to 1. When I plug in 1, I get 1 minus 1, that's 0. Then I have 0 to the second power, that's 0. Third root of 0 is 0. 3 times 0 is 0. So this would give me 1 divided by 0. I cannot divide by 0, which means that there is one x equal to 1. That is where the derivative doesn't exist. This is a critical number of this function. Are there any x's that make this derivative 0? I have my derivative, and I set it equal to 0. The way to solve it is to multiply both sides of this equation by the denominator. If I multiply both sides of this equation by the denominator, on the left side I will get 1, on the right side I will get 0, because 0 times anything is 0. This is never true, which means that there are no x's that make the derivative equal to 0. This function has only one critical number, and that number is 1.